Okay, so last time we introduced the definition of subtraction, and just as multiplication can be written in terms of addition, isn't it interesting how subtraction can also be written in terms of addition? Of the opposite, right? I'm not saying subtraction means addition. When you subtract a number, it's the same thing as adding its opposite, right? That's how it works. So we talked about the symbol is confusing, how the symbol is used for different things. When is it a subtraction symbol? When is it an opposite sign? It's a subtraction when there's a number or an expression in front. It's an opposite sign if there's an operation in front or nothing in front of it, right? So this is 9 times negative 5, and this is 9 minus 5. And on your homework, what you'll be doing here, it seems a little painstaking, it seems like a lot of writing, but it's important to learn the definition, and that way when the problems get really confusing and really hard, you know how to deal with it. You shouldn't be guessing at this stuff. 13 minus 8, that's a minus sign. The minus sign becomes plus a negative, and then you're changing it back to something that we were looking at earlier, you see? This is just like something we were doing in problem set 3 and 4. This becomes 5, right? Now this one, negative 13 minus 8, that's a minus sign, that's not. So this minus sign becomes plus a negative, just like we were doing before, and now it's like something we were talking about earlier, negative 21. Similarly, this is negative 15x minus 5x. That minus sign becomes plus a negative. So this negative stays the same, doesn't change. So once you write it this way, you're less likely to make a mistake. Negative 20x is the answer, right? This is where it gets kind of subtle. This is a minus sign. This is not. This is an opposite sign, right? So this does not change. This stays negative 7. But this symbol becomes plus a negative. So this is what it looks like. This negative still is negative 7, but this minus sign becomes plus a negative. And then what you can do is you can get rid of the double negative, and the answer is 19. Now, eventually, maybe it'll be okay to go from the problem right to this step on one step and skip this step, but for now it's a good idea to keep it. But that's something that you'd probably do eventually. But you should be able to answer the question, how come when you subtract a negative is it the same thing as adding a positive? Here's the reason why, right? Reasons. Alright, let's do a couple more. Then I'll give you some to practice. Read it back. It's negative 20 minus 11. So you change the minus sign to plus a negative, so it becomes negative 20 plus negative 11. So the answer is negative 31. This one is 5 minus 11 minus negative 8. So that's a minus sign, and that's a minus sign. So these two symbols become plus and negative. The negative 8 stays negative 8, right? Now let's get rid of the double negative, and we're down to here. So you have 5 plus negative 8, 5 plus negative 11 plus 8. I get, let's see, 13 plus negative 11 is 2. That's right, the answer is 2. Alright, so here, that's an opposite sign, that's a minus sign. So this minus sign right here becomes plus a negative, and you get negative 13n plus negative 13n is negative 26n. This one, you get 2xy minus 3xy minus negative xy. Okay, that's a minus sign because there's an expression in front of it. That becomes plus a negative, see? This minus sign becomes plus a negative, but this symbol here in front of the xy, this stays there. Then we get rid of the double negative. This just becomes plus xy on the end. And then when you add all these up, if I add the 2xy plus the 1xy, I get 3xy. But 3xy plus negative 3xy is just 0. That's your answer. Okay, now in this problem set, though, the problems get a little more involved. Have you noticed that? Every time we develop an idea, the problems get more involved. So that's why it's so important that you have the basics down. Don't jump to the really hard ones. Focus on the easier ones first. Okay, 3z minus 5y minus z plus y. That's a minus sign, that's a minus sign. So they can both be written as plus a negative and plus a negative. So you get 3z plus negative 5y plus negative z plus y. Collect like terms. 3z plus negative z is 2z. Negative 5y plus y is negative 4y. You can leave it like this, but in Math 80, when you see an answer like 2z plus negative 4y, they generally change the plus and negative back to a minus at the end. So again, you talk to your instructor about how they want you to write it. And unless in my class, unless it specifically says change all the plus and negatives to a minus sign at the end, you could either one would be fine. But in Math 80, you should expect to see it written like this. Okay, this one, let's see. That's an opposite sign. That's a minus sign because there's a 5 in front, and that's a minus sign because there's a 3 in front. So we just keep this the same and change these two to additive form, and it becomes like something we were talking about in problem set 10, right? You see that? This is just like what we were doing in problem set 10. So then what do? We work inside the parentheses, and that becomes negative 5. And then we're going to do the multiplication, right? This is negative 2 times negative 5, which is positive 10. So you get negative 3 times 5 plus 10. So that's 15 inside the parentheses. Negative 3 times 15 is negative 45. All right. A couple more, and then you can do some. Okay, here's what I was talking about. Here's one where it becomes kind of more involved, and this is why we learned it this way. We're going to do this the same way. We do them all the same. When you have a problem with subtraction, change to additive form. The minus sign becomes plus a negative, this minus sign becomes plus a negative, and it looks like this, you see? This problem right here could have been something on problem set 16. Everything we do, it refers back to something we covered previously. All right, so now that you change the minuses to plus and negative, it's just like something we were looking at earlier. Now we use the distributive law carefully, and then what you can do is collect like terms. I get negative w plus negative 11. I'd probably write it as negative w minus 11, right? Okay, let's go over here. This one, ooh, what do you do there? It's 2 times x minus 5 minus, is that a minus? Yeah, because look what's in front is this big expression. Minus the quantity x minus 4. So there's 3 minus signs. That's a minus sign, that's a minus sign, that's a minus sign. Change them all to additive form. And this minus sign becomes plus and negative. You see that negative in front of the parentheses now becomes a multiplication by negative 1. That's how that works. So then when you distribute carefully, this last one becomes negative x plus 4. This becomes 2x plus negative 10. When you add like terms, you get x plus negative 6, which can be written as x minus 6. All right, go ahead, try these on your own. We'll go over them in just a minute. Okay, here we go. So we're reading the problem back and identifying all the minus signs. That's a minus sign because there's a number in front. And this is a minus sign. We're going to change this to additive form and this to additive form. It looks like this, right? When you're done. This minus sign becomes plus and negative. This minus sign becomes plus and negative here. See, follow the order of operations. Let's see. We don't need to use the distributive law here. Let's add 4 plus negative 7 and get negative 3. Write the whole problem down. Now inside these square brackets, you see negative 9 plus, what does this become? 9. And so inside the brackets, you should have gotten 0. And 2 times 0 is 0. Okay, over here. Let's just be really careful here. This is a minus sign because there's a number in front. This is not a minus sign, but this is because there's a number in front. This minus sign becomes plus and negative. This minus sign becomes plus and negative also. So we're down to here. The negative 4xy stays the same. It doesn't change. It's just the minus sign that changes. Let's get rid of the double negative. And you realize that these do not cancel. This is in fact 8xy plus negative xy. I get 7xy. Okay, this one, let's see, read it back. This is 3 times the quantity 2 minus y, minus, because there's a number, this is a number, the quantity 2y minus 1. So there's 3 minus signs. So just change the minus signs to additive form. And like I was saying, this is exactly like what you were doing in problem set 16. If you can do that first step, you've changed this problem into something where you know how to do it. Use the distributive law carefully. Remember, this minus sign becomes plus and negative, and that negative is really negative one that's multiplying. So when you distribute it, you should have gotten negative 2y plus 1. When you add like terms, the y's gives you negative 5y, and this gives you 7. 7 plus negative 5y, or you could say 7 minus 5y. There's other ways to write your answer, by the way. If you had written it as negative 5y plus 7, then you could have just left it like that. These two things are equal, right? Because if you switch the order here, the commutative law works in addition. It doesn't work for subtraction though, so be careful. All right, so here, let's see, we're going to change to additive form. This is a minus sign, and so is this. This is not. This is just a negative sign. So we change to additive form, and it becomes like something we saw in problem set 16. this minus sign becomes plus and negative, and we're going to distribute that -1 through. So it becomes this. Inside the square brackets you add like terms, and then when you multiply, my final answer is -18x plus 4. Alrighty, we'll see you next time. Bye-bye.